Hi everyone, let me walk you through what we will be building today. Using the power of NVIDIA's free generative AI models, we've built ProteinBind, a drug research platform that helps pharmacologists and drug developers find molecules with the right properties, aiding in drug research. In this single video, you'll learn how to use the latest Next.js14, build an API in Next.js, store data in MongoDB with functions, utilize NVIDIA's open models to build your Next AI applications, implement user verification by email, forget password, sign in and sign up, implement real-time PubSub architecture by ably, utilizing context API, styling with Tailwind CSS, implementing protected route, and so much more. If this sounds interesting to you, pause and hit the like button and share. So this is the sign up page. A user enters their first name, last name, email, and password, including bio, and select a profile picture to sign up. I've already signed up, so I'll just click on the sign in. And on the sign in page, a user can reset their password. So when I click on reset password, it takes me to the forget password page where I enter my email and a link will be sent via this email to reset my password. So back to the login, I enter my email and password, click on sign in. And as soon as I sign in, my profile and username appears over here. So this is the dashboard page. So let's move to the molecules bank page. So we have common molecule name, their small structure, molecular weight, category usage, and we have aspirin here, caffeine, benzene, glucose, and so on and so forth. So next, we click on the model page where we have this generate molecule. So we are using the power of NVIDIA AI to generate molecules that will aid in drug research. So when I click on generate molecules, I have these molecules generated. So all these are coming from the NVIDIA AI. So this is the NVIDIA model that we are using. It's called Molmin. So this model, as it says here, it performs controlled generation, finding molecules with the right properties. So we have that, and everything that we search is being stored in the database, the MongoDB, so that we can access this later on. So we have the history of what we've searched, and we have the research page where drug researchers can search for a compound. So for example, aspirin, and we get all this information. So we have the basic information like the molecular formula, we have the molecular weight, and additional information, we have the physical properties. So all these are information that may help a drug researcher in carrying out a research for a drug. And finally, we have the message section. So this message page is to help drug researchers collaborate with each other. So we can create a group named, so for example, test group 1, hit on enter. So we have test group 1 created. I'll refresh this page and click on join group. We have the test group 1. So we can communicate to each other. So once I send a message here, so for example, hello world, and click on send, we have the message sent or broadcast in real time. So I have it here and also here. Can write hello world. This is working so good. Click on send. And boom, we have it over here. So this is a real-time chat functionality that is going to help researchers collaborate with each other. We have the settings page where a user can update their information. So we have the toggle theme to toggle between light and dark mode, and a user can change their profile and add and modify their personal information. So I'll click on save and refresh this page to see if my profile is going to be updated. And there we go, I have my profile updated as well. So this is what we are going to build in this video. So during the demo section, we had this small string and these parameters over here, number of molecules, minimum similarities, particles, iterations, to generate a couple of molecules for us. So this string here is what we call the small string. And I believe this is new to many of you guys watching this video right now. So I would like to give a brief overview of what small string is, and then we pick up things from there. So SMILE stands for Simplified Molecular Input Line Entry System, which is used to translate a chemical's three-dimensional structure into a string of symbols that can be easily understood by the computer software. So this is a chemical structure, and we can think of a SMILE notation as a compressed version of a large chemical structure. So we have code and symbols to represent these SMILE notation. So this is representations of atom. So we have methane, which is CH4, and it is being simply represented as C. And we have O for water, we have N for ammonia, we have P for phosphine, and we have S for hydrogen sulfide. So these are the SMILE notation among many other notations and their corresponding atomic symbols. And the SMILE notation is having its own unique way of representing a bond. So for a single bond, we have a dash. And for a triple bond, we have a hashtag. Double bond is represented by equal symbol, and aromatic bond is represented by column. So we have few examples here. Formic acid is a double bond. So we have the equal sign representing this as a bond. Same applies to ethanol and carbon dioxide. So yeah, we have these examples. And we also represent, and we have branches. So we have representation of branches as well. So branches are specified by enclosures in parentheses. So for example, this compound here is having a branch. So we represent that by a parenthesis. And this equal symbol here is a bond from what we learned over here. So it's going to be a double bond specifically. And we have a notation to represent a cyclic structure. So when we have a look at this compound, we have C1 here. So this one here is representing a ring. So this is the start of the ring and this is the end of the ring. So we represent that by using this notation. So from now, when we see these small notations, we shouldn't be scared. So these are just, atomic representations, and the parenthesis, as we learned over here, is a representation of a branch. So we have a branch and we have a bond here, and so many other notations. So we couldn't go through every single of these notations, but we covered the most essential ones. So I think that will be it for the SMILE notation. So I'll quickly move over to this page to discuss the functional requirement and the non-functional requirement for this project. So starting off with the functional requirement, we have the user authentication and management. So a user should be able to register with an email and password, log in with email and password, verify email after registration, and reset password via email. So the molecule management is basically giving the user the ability to browse a predefined molecules, search by SMILE notations, and view molecule data such as the molecular weight and formula. And we have the molecule generation. So the molecule generation is using the power of NVIDIA AI to, accept a SMILE notation, have a parameter defined like, the number of iterations and similarities to generate molecules. And after generating the molecules, we store them inside the database. Back in the demo, we discussed collaborative research, where researchers can communicate to other researchers to create a drug. So a user can create groups, add members, and send message within groups. And we have the non-functional requirement. So these are going to be the important metrics that we will be needing for the project. So performance is one of them. We want all the pages and APIs to load within the 2 to 3 seconds time frame, and it should be scalable to support 1,000 plus, 1,000,000 plus users. And the app should be usable. So the interface should be user-friendly and support both light mode and dark mode. And we have security section, so all the sensitive data must be encrypted, like the password, most importantly. And our system should be available 99.9% all the time. And our code should be maintainable, so to follow a standard practices and to be well documented. And finally, we have extensibility. So the system should be modular. We should be able to add new features to the application anytime that we want. So next, we are going to move to the user flow diagram. So this is going to be the flow of how a typical user is going to use our platform. So we have this little boy here, a user who visits our platform, our website, and signs up. So the user is going to fill the sign up form by entering the email, the first name, the last name, password, bio, and photo. Upon filling all these forms, the user is going to be sent a verification email, which is going to verify the email for the user. And once the verification process is done, the user is being sent to the login page, to the dashboard. And upon logging in or visiting the dashboard, the user has numerous actions to choose from. So the user can view group details, create molecules, generate molecule based on smart string, and search for compounds. So these are the few of the many actions a user can take on our platform. So this is going to be the system architecture for the project. So we have the front end and the back end. So the front end is using React.js and Next.js as its main technology. And we have the following libraries: RDKit for converting a small string or a small notation into an image. We have React Apex chart, which is going to be used to generate charts for this project. Tailwind CSS for styling the project, and NextAuth for handling the section and managing the user authentication. So we are going to have numerous components. So examples of the components are the header component and the molecule table component. On the back end, we have Next.js. We are still going to use Next.js as our back end technology. And the database is going to be MongoDB, which we are going to use the Mongoose framework for communicating to the Mongo database. So the pattern we are going to devise for this project is the MVC pattern. So we are going to write, our APIs to communicate direct to the databases. So we have APIs for authentication, APIs for group messages, API for sending emails, and so much more use cases. So everything is going to be handled by the API. And last but not the least, so we have the database schema. So the schema, we have three main schemas: the user model, the group model, and the molecule bank model. So the user model is having these properties in its collection. We have the email, which is a string. We have the first name, a string. A password is a string which is going to be hashed. And we are going to store the image in a byte 64 as a string, and insert it into the database. and we have all the other properties for the user model. And we have the group model with a name created by members. And we have the messages field here, which is going to store the user ID as a sender and store the text and also the timestamp. And we have the molecule bank model as well with these properties. So we also store the molecules, the structure as a string, and the score as a number, as demonstrated in the demo section. So without much talking, let's get right into business. So if you have been following my YouTube channel for a while, you will notice that this is a pattern that we use more often. So we usually have the starter file, which we clone and work with it. So the main reason why I do this is for the sake of those who would like to code along. So you clone this code and follow through the entire journey. So we click on code, select SSH, copy this and open our VS Code. So I have my VS Code opened and I will launch my terminal and run the following command. So let's clear everything and run git clone, paste the URL that we copied, followed by a period. So we have the code cloned and we have to install all the packages that we'll be needing to run this project and have a tour on the starter file. So to install all the packages, we are going to run npm install. So npm install, and we wait for a while for this to get installed. So whilst this is installing, let's take a quick tour on what we have in the starter file. So we have a public directory which contains the images that we'll be needing for this project. So we have the logo here and this folder named user with one image, and we have this image which is the default avatar for the project. So if a user hasn't signed up, we have this default avatar. And in the src folder, we have the app directory, we have the layout, the page.tsx, and we have the styles.css file, which contains all the styling for this project. So I think that will be it. And we have tailwind.config.typescript, which contains configurations for the project. So that will be it, and let's check on the installation. So I think everything is installed. Alright. So I will split my terminal into two and clear everything, run npm run dev. So we have the code starting on localhost port 3001. So we move back to our browser, type localhost port 3001. And we have default layout rendered here. So I think this is what we were expecting, because when we check the page.tsx in this app directory, we have default layout. So that is what we were expecting. And so this is going to be our development URL or port. And this is going to be the complete project URL. So we'll be comparing things side by side with what we are building. So the first thing we are going to tackle is the default layout. So let's move back to VS Code. So the first thing we are going to work on is the default layout page. So we are going to create a folder inside this SRC directory named component, which is going to house all our components for this project. So new folder, component. So inside the component, we are going to create a new folder named layout. So layout, and create a file inside the layout folder named default layout. So we create a file named default layout.tsx. So we are going to import the use client over here. So this is going to indicate that this code should run in the client mode or the browser mode. And we are going to import React from React, and we will be needing this hook. So we have the use state hook, and we have the use layoff effect, which is going to be useful later on in this project. So we have these two hooks imported. So next, we are going to export default, a function named default layout, which is going to have a children. So this default layout is going to be a parent component which accepts or expects children as a props. So we have that, and the type of the children is going to be React.React node. So inside this layout page, so the layout page contains, when we see the complete project, we have the sidebar and the navbar. So we have the sidebar and the header. So these are the main components of the default layout, and everything else is rendered as a child. So we are going to create a sidebar and a header component. So we have to return a div. So we are going to have a div, a parent div, which is going to have a class name of flex. And inside the div, the first component is going to be the sidebar, which I'm going to replace with a comment. And we create, another div, which is going to be the styles for the header component. So I give it a class name. We have relative, flex, flex1, flex call, and on the last screen, we want the margin left to be negative 72.5. So we have this, and I am going to have a comment here that says header, because later on we are going to import the header component over here. So we have the main. So the main content area, which is going to house the children. So every component that is going to have the default layout as a wrapper. So we have the main, and it have a div. We give it a class name, mxauto, mass width of screen 2SL, padding of 4, and on the dark screen, we want to give the background color this color code. So hashtag 121212. And on a medium screen, we want to have the padding to be 6 and 2SL P10. So inside this div is where we are going to render all the children. So we have the children here and we save that. So we are going to create the sidebar and also the header before we continue or leave this default layout page. So inside the component directory, let's create this new folder named sidebar. Okay, so it should be inside the root directory of the component. Alright, so we have sidebar. And inside this sidebar folder, we are going to create a couple of files. We are going to create these three files. So we have the index.tsx and we have the sidebar dropdown.tsx and we have the sidebar item.tsx. So we are going to I'll be explaining the uses of each of these files. So we select the index.tsx and we are going to call the use client here to indicate that this component is rendered on the client side. So this sidebar is going to contain the links to navigate to various pages in this project. So when I click on navbar, when I log in and click on molecule banks or move to any other pages at all, we can see this is a link. So we are going to import use path name from Next navigation, which is going to help us to access the current route. So we import use path name from Next navigation and we import link from Next link. We are going to import image as well. So import image from Next image. And we are going to be needing a sidebar item. So for these items here, we are supposed to create a component for them. So we are going to create the sidebar item component and import them inside the index.tsx. So the sidebar item component. So we are going to import React from React, import link from Next link, and we are going to need the sidebar drop down here. So we are going to create that and then get back to the sidebar item, complete this component and move back to the index and complete this as well. So let's create the sidebar drop down. So the main reason why we are creating this component is that we have an additional property to determine if a link is a drop down or not. So if that property is specified, we want to render that. So that's the main reason why we are having the sidebar drop down. So I am going to paste the sidebar drop down code here and explain it line by line. So we are importing React as usual. We have the link from Next link and we are importing the use path name from Next navigation. So as I mentioned earlier on, this component is going to be used to render a drop-down list of link in the sidebar. So we get the current path name from Next router for the active link highlighting. So we get the name here, we store that, and this map here or this item we are getting is coming from all the navigation link items. So this sidebar drop down accepts an item as a prop, which is going to be the array of objects containing the name, icons, and the links of the URL or the sidebar items and loop through them to render the sublinks. So we have this conditional class here, which is going to apply a test white class if the current route matches the links route. So that will be it for the sidebar drop down. We save that move back to the sidebar item and import the sidebar dropdown. We are also going to need the use path name here from the next navigation. So we have that. So we are going to create the sidebar component. So you write const sidebar item. And this is going to have the item as a prop, which we are going to pass down from the index.tsx. So we have item, we have the page name, and set page name function as a prop. So we are going to have a function to handle when an item is clicked, toggling the drop down if it exists. So we create a constant handle click. We have const update page name, and we have page name, which we are accepting from, which is coming down as a props from the wherever we call the sidebar item. So we check if the page name is not equal to item.label to lowercase and we have item.label dot to lowercase and we return set page name to update page name. So we are going to create a constant that is going to get the current path name from next router to identify the active route. So we have const path name, which is going to be use path name. So we are going to have this function here, which is going to recursively check if the item or any of its children matches the current route. So we have this function here is active, which recursively checks if the item or any of its children matches the current route. So we are going to have constant is item active equals is active, and we have the item here. So this is going to determine if the current item or its children's are active. Then we return the following. And we are going to render a list. Inside the list, we are going to render the primary item in the sidebar. So we have a link, and we have href, which is going to be item.route. So we are going to create this item object when we get to the index page. So the item is having a property named route, and we have the onClick, which is going to handle the click. And we have this long CSS class name here, which is basically applying active styles when the item is active. So we have that, and within the link, we render item.icon and item.label. So this one's over here. And we have this another section here, which is going to render should in case we have a children element for the nav links. So we have item, the children, and we are going to have this here. So we have a div to apply styles to the children item in the navbar, and this sidebar drop down is also going to display the drop down. So if we have a children element, we click on it, it displays beneath the actual link item. So that's going to be it for the sidebar item, and we export this so that we'll be able to use it in other pages. So default sidebar item, and we give this a save. So back to the index, we have the sidebar item, the sidebar drop down. So let's continue on everything that we are writing over here. So we can import the sidebar item. So sidebar item from sidebar. So we have a couple of icons that we have to import here, which is going to be the icons for these sidebar items. So for this project, we are using this icon package here named Lucid React. Lucid React. When we check lucid.dev and click on icons, we can get any icons that we want. So we can, check the installation procedure, run npm install or yarn install Lucid React, and let's import the following icons. So back to our code, we are going to import layout grid, we're going to import atom, we have network, microscope, we have the settings, the meeting square text, message square text, not meeting, and the chevron left icon. So these are the icons we are going to import for now, and this interface is going to do two things. So you're going to have a boolean that indicates whether the sidebar is open, and you're going to have a function to toggle the sidebar open and close state. So we have interface, sidebar props, and we have sidebar open, boolean, and we have the sidebar set sidebar open, which is going to have an argument of boolean, and this is going to be a function. So I am going to copy and paste the menu groups over here, and these are the menu groups for the links. So we have this object which is having a name and a menu item. So this is the first group, the first object here, and this is the second group. So when we check the website, we have the first group here and the second group over here. So the second group contains only one item, which is the settings. And we have this group, so we can create as many groups as we want. So we copy the group and paste it at, So make sure you have the name, which is going to be the name of the group, followed by the menu item. So we have the item contains the object, which is the icon, the label, and the route. So these are the icons that we imported over here, and these are the routes for the specific menu items. So we have our menu groups. So you're going to create the sidebar component itself. So constant sidebar, and we are going to have sidebar props, sidebar open, and we have the set sidebar open, which is going to be the sidebar props. Alright, so we have that, and inside this component, we are going to have the path name. So we are going to use the path name hook to get the current route path name. So we have a constant path name and use path name. So next, we are going to create a local storage hook to persist the selected menu item across sections. So when the user clicks on the menu item, upon refresh, we want to keep the context of the selected menu item. So for that matter, we are going to create a local storage hook. So inside the SRT directory, we create a new folder named hook, which is going to store a couple of hooks for this project. So we are going to have the user hook, and then we have the use local storage hook. So I'll create a new file and type use local storage.csx. And this is going to house the code for storing context in local storage. So you are going to call the use client here up at the top of this line. So it's going to be the first line. And what this is indicating is that we want to run this in the browser. Since local storage is a browser object, we want to use the client to ensure that the code is a client-side code. And we are going to import use effect and use state from React. So we are going to create a TypeScript type alias called setValue. So this is going to allow the state value to be either the type of t or a function. So it takes the current state value t and returns a new state. So we type setValue with the type of t equals t. So we allow this state value to be either t or a function. So the function is going to be this one over here. So we are going to have this function here named use local storage. So this defines the custom hook that we are going to use, which is going to accept two arguments. So we have the key, which is a string representing the key in the local storage, and initial value, which is going to be the initial value of type t for the state. So we write a function use local storage t, and the arguments, we have the key, which is a string, and we have the initial value, which is a t, a type of t. So t, and we have the value to be set value of the type t, and void. So you're going to define a state here, constant. We have the stored value and set stored value equals use state. So we have this here, and this line initializes the state variable stored value with a value returned by the function passed to the use state. So this function is going to execute once, and it's going to happen during the first render to set the initial state. And we have a try catch block, and we have if. So inside the try catch block, we have if type of window is not equal to undefined. So we want to do the following. We want to retrieve the item from the local storage using the provided key. So we create a constant item, which is going to be window.localstorage.getItem. Pass the key, and we return item. json.parse item and initial value. So what this is doing here is if an item is found in the local storage, we pass it from the JSON and return it at the state. Otherwise, we return the initial value. And there's a try catch. So we have the catch, which is going to be an error. So we pass error as an argument and we log every error that we are getting. Console.log error. And after we are done logging the error, we are going to return the initial value. So in case there is an error, we have to return the initial value as the state. So we are going to use the use effect hook. So in this case, we want to update the local storage when the state changes. So we have the use effect hook here. So inside the use effect hook, we are going to have a try catch block to handle the potential error during the side effect. So I'm going to copy this code here and paste it over here. So what this is doing here is to, allow the stored value to be a function, which is similar to how useState works. So if the stored value is a function, call it with the current state to get a new state. Otherwise, we store the value directly over here. And we do a check-ins here, which is going to be if we check if the type of window is undefined. So if type of window is not equal to undefined, we want to set the window.local storage. So this is the JavaScript object to store local storage item. So you use the local storage object .set item. And we're going to store the key and JSON.stringify the value stored. So we have that, and we can provide the catch block here with an error, and we log the error. So next, we are going to add the dependencies to the use effect. So we want to run this hook, or we want to run this block of code when the key and the stored value changes. So if the key or any of these dependencies changes, we want the use effect to run, right? So we have that, and we are going to export default use local storage. So once we export default the use local storage hook, meaning we can use it in any other component. So that will be it for the use local storage hook. So let's move back to the index page of the sidebar and call the use storage hook here. So we have a constant page name, set page name, and we are going to use the use local storage hook, the one we created, and we are going to pass in two arguments. So the first argument is going to be the key of what we want to store. So in this case, we want to store the selected menu, and the value is going to be the dashboard, which happens to be the default value that we will be setting for this use local storage hook. So the dashboard page is going to be the default value as far as the selected item is concerned. So we have that, and we can return the component of the sidebar. So for the sidebar, we are going to use the aside element in HTML. So we have the aside element, and it's having 8 classes to position it at this side, including the background color and all that, the transitions and all that. So we have the aside, and we have a sidebar container. So we have a div which is going to be the sidebar header with the logo and the close button, which is going to be visible on small screen. So we have this div here. So let's add the closing tag. And within this div, we are going to have a link. The link is going to have an href equals, / indicating the home page. So this section we are creating here is what we have here. So the logo, and then, it's a link. When I click on this, it takes me to the home page. So that's what we are defining over here. So we are going to have a div. So I'll copy those divs, and they are just going to position the logo at the right place at the top of the sidebar. So let's add the closing tags for these divs. And within this div, we are going to have the image from Next.js. So we have image, which we are getting from Next.js, and we are going to pass in this property. So we want the width of the logo to be 32, the height to be 32, and the source of the image can be found in /images logo /dna.svg. So we have this DNA logo here. I have that here. So svg and alt should be logo. So in case this doesn't load properly, we want to display an alternative name named logo. And we add this here, priority. We save that, and so we are going to add a paragraph here to contain the name of the brand or the app. So we have the logo here and the name of the app here, and that is going to have a class name. We have a text, XL, font to be semi-bold, the text should be white, and the title is going to be ProteinBind, which is the name of the application. So ProteinBind. So we have that. And the top part of this sidebar is done. So it's left with this side here. So I'll copy this button here, paste it right here. So this button is going to be displayed on a small screen. So when we squeeze this screen to the mobile size, we have this hamburger icon here. When I click on it, I have the chevron left icon here, which is going to hide the sidebar on the mobile view. So this button is going to do that for us. And we have to chevron left. We have to import that from the logo. So chevron left. Chevron left. So we have that, and so the next div is the sidebar navigation container, which is going to allow vertical scrolling of the menu items. So I'll copy that. So we have that here. And the navbar itself, which is going to contain the menu groups. So paste that and close it here. And within this navbar, we are going to loop through the menu groups, the one we created up at the top here. So we are going to render all these menu groups. So this is the menu groups that we are looping through, and we display the group name at the top here. So we have others. This doesn't have a group name, and we loop through the items itself. So we are calling the sidebar here, this sidebar item component that we created, this very one. So we are looping through all the menu items and rendering them over the sidebar item. So we provide the item as the menu item. So each individual item you are getting from the menu items are passed down to this sidebar item component to render it inside it. So we have that, and I think that will be it for the sidebar component. So this is going to work fine. So before we can test this out, we have to import it inside the default layout page. And we have to, export default this component to be used inside the default layout page. So over here at the sidebar section, I'll call sidebar. And remember, the sidebar is having two arguments. So we have to pass in the sidebar open and set sidebar open. So back here, we are going to create a state at the top here. So let's create a state, use state, and we are going to have the sidebar open and set sidebar open. And the initial value is going to be false. So we provide those two props for the sidebar to work. So we provide the set sidebar open to be the sidebar opened, and the set, so the sidebar open should be the sidebar open, and set sidebar open is also going to be the set sidebar open. So once we have this, we can move back to local storage port 3001 to check if we can see the sidebar. So we click on this, we give it a refresh, and we are still seeing the default layout here. So we have to back at the page component. When we open the app and click on the page component, we have to call the default layout here. So we are going to get rid of everything here, and we are going to, call the default layout. So we have the default layout here, and let's provide just a paragraph, to indicate something like hello dashboard page. So we save that, and fingers crossed, everything should work. So I'll move back to this, and boom, we have the sidebar rendered beautifully. So next, our target is going to be the header here, which is going to include the input for searching, the chat drop down, the user drop down, and we pick things from there. So we have hello dashboard. But before we move out from this page, we will come back to this page to import the index component, which is going to have, when we log in, so the index is going to show all these for us. So we are going to get back to this component and import that. But this is very important. Let's define a metadata for this page. So we are going to import metadata from Next. So this metadata is going to help in search engine optimization. So we have export constant metadata, which is going to extend the metadata we are importing from Next, and it's going to be an object. So the title of this page should be, ProteinBind, a leading research platform for drug discovery. And we can add a description. So the description could be, anything at all. So you could write a paragraph, a whole paragraph here. So I'll just make this is a description. for ProteinBind. So you can be creative here and add, a whole lot of description to help to help search engine optimization. So anyone that searches for ProteinBind or anything related to research for drug discovery, this page should be a priority in the Google index, in the Google search index or the Google rank. So inside the component folder, we are going to create a new folder named header. So the header is going to contain everything related to the header component. And inside this, we create the following files. So we have index.tsx. We have the dark mode switcher.tsx. We have the drop down message.tsx. And then we have the drop down user.tsx. So I'll close these and start with the index page. So before we start writing code for the index page, let's create the drop down message component and the drop down user component. So starting with the drop down message component. So this drop down message component, when I click on this, it takes me to the message section. So that's basically the function for this drop down message component. So I'm going to paste the drop down message component here and explain everything line by line. So this is the drop down message component. We are importing the use state and link from Next.js. So this message circle more icon is coming from Lucid React. So when we search for message circle more, we get this icon here. And when we check the complete project, we can see that is the exact icon we have over here. So we have that imported and we create a state for the dropdown opened and set dropdown open. So initially this state was used to, this was a dropdown component that listed, all the messages that the user is getting, right? But later on, I took it out for some reasons. I wanted you guys to be adding more features to this project. So I didn't want to, build everything for you guys. But as a test, to challenge your skills, you have to build the rest of the components and, make this comprehensive. So I have that state over here. And we have a state for notifying. So this notifying state is the red. So it's the red dot animation over here, which is indicating that there is a message. And we have a link, which is to, set the notifying to false. So once we click on this, the notifying is going to disappear. So I click on this and the notifying is gone. So that is the uses of the notifying. So when a user click on this message icon, I want them to be directed to the messages page. That's why we have this link here. So we have this class here, which was part of the drop-down opened section. So you can work on that, and we have the message circle more icon, which we are displaying over here. So this is a very basic component. The drop-down message is a very basic component. And next, we move to the drop user component. So let's write down the code for the drop-down user. We are going to call useClient, and we are going to import useState from React. So import useState from React and import the following icons from Lucid React. So we have the chevron down, logout, settings, and user icon from chevron from Lucid React. So we will be needing the use router from Next Navigation. So we call that as well use router, and import image from Next image. So next image. And we are going to import link from next link. So import link from next link. So we are going to create a constant named drop-down user, which is going to be the function to contain the drop-down user. So we have that, and so we are going to create a state to determine whether the drop-down is opened or not, so that we can toggle between the open and also the closing state. So we have a constant, and we have drop-down open. We have set drop-down open. We have the use state to be false. So the default value is going to be false. And we have the router, which is going to be use router. And we are going to return a div to house everything for the drop-down component. So inside this div, we are going to have a link which is going to toggle the drop-down visibility. So they have a link, and we have the href to be a hashtag. So href hashtag is preventing the default behavior of a link. So we have a class name to be flex, items center, and a gap should be 4. And we have an onClick event here, which is going to set the drop down open to what the initial state is not. So if it is open, we want to set the drop down to the opposite and vice versa. So we have that, and we can create the other sections for this drop down user component. So we have the link. So on a large screen, we want to show this. So we have a span here, and the span is having a class name of hidden. On a small screen, this is supposed to be hidden. So we have the text right, and then on a large screen, we want it to be displayed. So we give it an LG of block. And what we're going to do inside the span is to display the username and the job title. So the username and the job title. So the first span is going to display the username, text small, medium, font is going to be medium, the text is going to be black, and on a dark screen, on a dark mode, we want the text to be white. So we have that, and we are going to display the user's first name and last name. So when we are done creating the authentication for this project, we are going to create a user hook which is going to store all the section of the current user. So it's going to be something like user.firstname. But since we don't have authentication in place, we are going to replace this with a random string. So the random string is going to be something like, John to be the first name, and the last name is Doi. So we have this span to take care of that, and this span to take care of the job title. So the job title, we want to display, drug researcher, and provide the following class name. So block text extra small. We give this a save and create the profile section. So we have a span to take care of the profile. So we give this a class name of H11, W11, rounded full. We have the image from Next, and we provide this with the width to be 80, the height to be 80. We have the source of the image. So by default, this is supposed to, come from the user, the stored user in the section. Since you don't have authentication for now, we are going to replace this with the default user image. So back in images directory, we are going to navigate to user and then user01.jpg. And we have the alt to be user. So we provide a style, a width of auto, and a height of auto. So we have that, and that will be it for the user. So let's add the chevron down icon, this one here, to show the drop down. So I'll add this chevron down icon, and the final part of this section is going to be the drop down menu. So when the user click on the chevron down, we want to display the drop down menu. So this is what we are going to do here. So we are going to make a condition to check if the drop down is opened. And if it is opened, we want to render the following. So we want to render these items. So I'll paste this, and so we have the my profile, the account settings, and the logout button. So I'll comment this out, and that is going to be it for the drop down user. So we have the drop down message, the drop down user. Let's work on the dark mode switcher. So before we work on the dark mode switcher, we have to create a hook called the use color mode hook, which is going to handle the light and dark state of this entire application. So inside the hook, we are going to create a new file named useColorMode.tsx, which is a hook, and I'm going to paste that over here. So what this code is doing here is using the useStorage hook that we created to store the color mode. So if the user selects the dark theme, it is being stored in the local storage, and upon refresh, we still get the theme available in the context. Same for the light mode and all that. So this is a basic component. I'll give that a save and move back to the dark mode switcher. So this is going to be the dark mode switcher component, and we call the use color mode hook. I'll comment this out and call the use color mode. All right, so we have that, and so what this state is doing here is to hold the current theme, so the light or the dark theme, and the set color mode is a function to change the theme. We have a label that acts as a container for the switch, and we have this hidden checkbox input that toggles the theme when changed, and this part is the visual part of the theme. So when we check the complete project, we move to settings. We have to log in first and move to settings. We see this over here. So this is an SVG for the sun, which is representing the light mode. And when we click on this, it turns into a moon representing the dark mode. So all these are SVGs. So those are the ones we have over here. So that will be it for the the dark mode switcher component. So back to the index of the header component. So this is the component for the header, right? So we are importing the drop message, the one we created. We are importing the drop down user. We are importing the search icon from Lucid React. So this header component is responsible for managing the header bar, so including the sidebar toggle, the search, and the user dropdown. So this header accepts a state to track whether the sidebar is opened or not. And we have this function to toggle the sidebar's open or closed state. So we want to stick this header to stay at the top while scrolling. So when we check the production code, this header bar stays at the top. So we have the sticky property over here to do just that. And this side here, this div here is the sidebar toggle button for smaller screens. So this is going to be visible only on smaller screens. And we have this section to display the search icon and the search bar. So this input is responsible for the search bar, and then this is for the search icon, what we have over here. When we scroll down a little bit, we have the last div, which is responsible for the drop-down message component and the drop-down user component. So with that, we can save this header component, move back to default layout, get rid of this comment, let's leave it, and then import the header component. So header. So the header component is also having, the state which I explained earlier on. We have the sidebar open and the set sidebar open. So we are literally going to copy what we have here, paste it over here, and that will be it for the header. Yeah, so let's give this a save and move back to localhost port 3001. So when I refresh this, it says use router. So next router was not mounted back in the drop-down user. So let's move back to the drop-down user and use router was not mounted. So what could be the reason for that? And okay, so the use router is supposed to come from the next navigation, not the next router. So next navigation. So let's give this a save, and there we go. We have the search bar, we have the message drop down, and we have the user drop down. So we are mixing the image. Let's move back to this side. So public, we have images, we have user and user. Okay, so the image is PNG, not JPEG. So PNG, move back, and there we go. We have the drop down working fine. So right now, everything is coming together. We have the sidebar, we have the header, and what is left is to build the component, the main component for this project. So I will clear everything, close all, to have a clean, Visual Studio Code environment, and minimize everything. So next, I want us to work on the authentication, that is connecting the databases and, creating all the functions for the API to insert a new user, to create a group, to insert messages, send email to the user to verify the account, forget password, API, and all that. I would like us to work on the home page. So when we check, we just have hello dashboard page, which is coming from this side here. The pages, the page component. So I want us to replace this with, an actual component to display the home items, like what we have in the dashboard. So when I sign in, this side over here. So let's create this component and, start working on the database. So inside the component folder, let's create this directory here and name it dashboard. So this is going to contain most of the components and, functions for the dashboard. So we have dashboard, and inside the dashboard, let's create this folder named component. Components, and we are going to create an index file inside this dashboard folder, index.tsx. And for the component, we are going to create all these components for the dashboard. So we are going to have, our first component is going to be the CTA card.tsx, and we have the dashboard card chat.tsx, and we have the dashboard card map.tsx. So basically, these are the CTA cards, the call to action cards, and this is the dashboard card chat, and this is the dashboard card map. So those are the components that we've created over here. So starting off with the CTA card. So in the CTA card, we are importing the arrow right icon and React, and also React node. So we have the arrow right icon here, and we are creating an interface, and then we create an interface which is going to have a title, a subtitle, and a children. So inside the component, we are extending the card props, the CTA card props, and we have the title, the subtitle, and children as a prop. So over here, we render all the children, and in this div, we render the title and also the arrow right icon. So we have the subtitle also here. So title, subtitle, and the right arrow icon. So that's basically for the CTA card component. So we are going to call this at the index.tsx and provide all these props to make sure we are getting all these rendered. And then we are going to move to the dashboard card chat component. So this is the dashboard card chat component, and inside the component, we are just, returning all the elements inside the component. So we have the collaborate with team, and so this one here, and this section, which is a mockup of a chart. So, we have the div, we have an image. So we have a div here, which displays this chart here, the name, the time, and the description, right? So this is just a div, and with a styling that, separates the icon from the div here. So we have this flex row here, and everything is aligned side by side. So that will be it for the, the dashboard card chart component. So we save that and create the dashboard card map. So for this project, we are going to use JS vector map. So when we search for JS vector maps over here, and click on this link, it takes us to this page. So when I click on discover now, we have, all the documentation for JS vector map. So we have basic examples that we can use, and we have available maps. So we have the world map, we have, US map, and all that is available over here. So when we check our project, we can see we are using the world map. So this map is a world map, and to be able to use the world map, you have to download this. So when we click on this download, it's going to, give you this long JavaScript code here, which you have to copy. So I'll copy everything here and move back to the application. So I'm going to create a new folder inside the SRC directory named JS, and create a new file named world.js. I'll paste the code I copied from the vector, JS vector, paste it here and save it. So this is going to be the code for the world map. So everything here is pure JavaScript. So we have these properties and SVGs and all these other code to make sure the world map is is visible and is interactive as well. So we have that, and inside the dashboard card map, so this is supposed to be card and not car. So inside the dashboard card map, we can import the JS world, that we just created, this file here, which is going to be important in this use effect. So once we import JS vector map, we have the dist. So we import the JS vector map, we import the styling, we have use effect from React, and also the JS world that we just created, we can render the map. So over here, we are using use effect hook to run the code after the component mount. And this section here is initializing the JS vector map with this option. So the selector is a DOM element where the map will be rendered. So we have selector to be map 1. You can read more on how to use the JS vector map on the official website. And we have the map to be world. So we have this world map. If we don't import the world map over here and we specify any of these maps, either Spain or Russia or Canada, we are going to get an error. So make sure every map that we are calling here, being it world, United States, we have to have the file created somewhere. So inside the JS folder or inside the components folder. And we have the zoom buttons to be true, which is going to enable zooming on the map. So all these are just for styling for the map regions. And we have the text all over the world. This one here. And, we display the map over here. So we have the ID map 1, which is basically the same as the selector that we created over here. So when we save this and move back to the index page, we can now call everything here and render it inside the page component. So I'm going to paste the code here. And this is basically, what we have. So let me rename this to card, not a car. Card, and save it. All right. So we import the use client here, and we have dynamic import from Next and React as usual. We import the CTA card from the component, from this component, CTA card. So so we are importing these items or these icons from Lucid React. The atom icon, the message, the network, and search icon. So we call or import dynamically the dashboard card map. So dashboard card map. And so this means we don't want to render this on the server side. So we are disabling the server side rendering. Same for the dashboard card chart component. So we call the card component provide all the props needed for it to run. So we have the subtitle, the title, the atom icon, which is a child. So when we inspect the CTA card component, we are rendering the child here. So the icon is going to be displayed as a child, like what we have here. We do same for the rest. We do for generate molecule, search compound, and collaborative research. And then we, call the rest of the component. We call the chart card and then the map card. So let's save this and move back to the page.tsx, get rid of this paragraph, and we are going to call the index. So index from component dashboard. Give this a save, move back to localhost port 3001. What do we have? So we are having this error saying we don't have this file, available in the project. So I'll move back to the dashboard card map and get rid of this one. Move back, and there we go. So this is happening on port 3001. So meaning everything is working fine. So we don't have the image here. Let's work on that. Back to card chat, public images, user. So user01.png, save that, and boom, we have the user image here. So we have the index page or the dashboard page, working. Our next target is going to be the database connections and writing all the API functions. So we are going to create an account on MongoDB website and get a connection URL. So back to the browser, we are going to search for MongoDB and click on this link. So before we can get the connection string, we have to create an account. So I will search for MongoDB sign up and click on this register icon here. So to register, we have to, create an account. So you can use Google or GitHub. So you select any Google account that you want to create the MongoDB account with. So I'll click on this and select an account. So if you selected a Google account, you are supposed to see this page. So I'll click on I accept the privacy policy and submit this. All right, so this is the onboarding page. You select your primary goal. So, just select anything at all. This doesn't really matter. So just select anything. And the programming language we are going to work with is JavaScript. So we just select, not sure, so none. And the type of application we are going to build, not sure, and click on finish. For MongoDB, we have clusters, right? So we have the M10, which you're going to be charged 0.09 cents per hour. And we have the serverless, and we have the free tier. So what we are going to select is going to be the free tier because we don't want to be charged. So we click on this M0 and we give this a cluster name. So it could be anything at all. So I'm going to leave it as cluster 0. And scroll down. So all this doesn't really matter that much. I'll just leave the default one selected by Mongo for me. And I'll leave everything untouched. Click on create deployment. So you can create a username, and my username is going to be ProteinBind. So copy this somewhere and create a database user. Click on this. And then we choose a connection method. So we are going to use drivers. And let's select Node.js 2.2.12 or later. And click on done. So we have these clusters. Under the deployment menu, let's click on database. And this is where we are going to get the connection strings. So we can click on connect. Select, drivers, and we copy this connection string. So the password we copied is going to be replaced over here. So I'll copy this and create an environment variable to store this MongoDB URL. So I'll move back to VS Code and create a .env file. So we have .env, and I'm going to have MongoDB underscore URL. Then I paste, this connection string over here. So let's paste the password, the DB password. Paste it over here. And we have, the URL for the MongoDB. So we give this a save and move back to the MongoDB website. So once we configure the MongoDB inside our project, everything we are going to store is going to, be at this database section. So we are going to get a collection created and, the items in the collection or the data in the collection. So let's move back to VS Code and start writing the APIs to, connect or communicate with this database. So inside the SRC folder, let's create a new folder named lib, which is going to contain all the logic for the database. So we have lib, and inside the lib, we are going to have actions folder. We are going to have databases or database folder, and I think that will be it for the lib. And let's create this folder named types, which is going to contain the Typescript types for this project. So inside the lib, let's create this utils function or file, utils.typescript. And I'm going to copy and paste that code over here. So the utility function is containing two functions. So the first one is to handle errors for our database, and the second one is to resize the image. So when the user signs up, we want to convert the image to base 64 and store it as a string inside the database. So we don't want to, store that huge size file inside the database, and we have to compress it. So this resizing is sort of acting as a compressor as well, to have or to give the image a maximum width of 100 and a maximum height of 100. So that's what this function is doing over here. Resize to base 64. We save this. So inside the databases, let's create this file here named mongoose.typescript. So this is going to contain the code that is going to connect us to the database via the URL that we just copied from MongoDB. So we are going to import Mongoose. Importing Mongoose. From Mongoose. So as I mentioned earlier on, Mongoose is a JavaScript framework that helps us, to write functions to easily communicate to MongoDB. So this is going to have functions like to insert, to find, to delete, and update. So it's going to make everything simple for us. And we create a constant here to hold the MongoDB URL. So we have MongoDB URL, which is going to come from the environment variable. So we have process.env.mongodb URL. And then we are going to create an interface. So the interface is going to be the Mongoose connection. And this is going to be a very simple interface with just two parameters. So we have a con, which is a short form for connection, to hold the Mongoose instance. And we have null here. If there is no connection, we want to return a null. And we have a promise. Since, connecting to database takes time, so we have to, wait for it to connect before we communicate or interact with the application, which is going to be a Mongoose type, and return null if we don't have anything. So we are going to declare a cached connection object, stored it globally to maintain the state across modules. To maintain the state across module reloads. So we have let cached Mongoose connection to be global as any of a type of as any, and Mongoose. So we have that, and we are going to check if the cached object exists. So if it doesn't exist, we create one. Otherwise, we leave it like that. So if not cached, this is what we want to do. We want to, create a cached, which is going to be global as any dot mongoose. So we have the con null, and we have the promise to be null, and we are going to create a function to connect to the MongoDB database. So we have export const, a constant connection, connect to database, which is going to be an async function. So we check if cached.con, we are going to return the cached connection. So we don't want to be connecting this anytime a user wants to interact with the database. We want to cache this connection. So if we have the cached connection, we don't do the connection. So if the cached connection is available, we just return that. Else, if we do a check-ins to check if we don't have a MongoDB URL, we are going to throw a new error and specify missing MongoDB URL. So if all these are being passed, right, we are going to create a cache. So if there isn't an existing connection promise, we create one. So we have the cached.promise, and we have the cached.promise, which is going to be mongoose.connect with the MongoDB URL, specifying this object. So we have the DB name. So what is the database name for this project? We want to give it a name for ProteinBind. So you can, replace this with any name of your choice at all. So if you want to reuse this code in a different project, you can rename this DB name to something else. And we have the buffer commands, which we are going to turn it to false. So we are disabling buffering of commands to avoid issue with reconnection. And we are going to wait for the connection to be established and cached it. So we have the cached.connect, and we are waiting for cached.promise. If everything is okay, we are going to return the cached.connection. So that's basically what we have in the Mongoose page, this mongoose.typescript page. So next, we are going to create the models for this project. So we have 3 models. So let's create a folder, models. And inside the folder, we are going to create 3 models. So the first model is going to be group.model.typescript. And we have user.model.typescript, and we have molecule generation.model.typescript. So starting off with the user model. So we are going to import these from Mongoose. So we are going to import schema, models from Mongoose, and create the user schema for the user collection. So we have user schema, new schema. We specify this object. So if you skipped where I explained the database schema back in the introduction section, you can go back and rewatch that to understand, how all these schemas are going to communicate with each other. So the first object we are going to create is going to be the email, which is going to be a type of string, and required is going to be true, and we have unique, which is also going to be true. So we save that and we create a full name schema with a type very similar to this. So we copy this, and the required is going to be false. So required is going to be false, and unique is also going to be false for the full name. And we have the photo, which is going to be type of string, and required is going to be true. So we have the first name, which is having a type of string, and we have second name, last name, with a type of string as well, and we have the password, and we have a password with a type of string, and required is going to be true. So we're going to hash the password using bcrypt, and we're going to have a state to check whether the email of the user has been verified or not. So is email verified? We have the type to be Boolean, and we have the default to be false. And we are going to have user verification, and we are going to have user bio. So user bio, and the type is going to be a string, and default is going to be an empty string. So you're going to have verification token, verification expires, reset password token, and reset password expires. So I'll paste that over here. And finally, we are going to have a timestamp. So the timestamp is going to be true. And we create a constant user equals models.user. So we create the model with the user, the model name to be user, and we pass in the user schema. And finally, we export the default user. So the molecule generation is going to follow the same pattern. So we are going to have the schema, the model, and models imported from Mongoose. And we are going to specify a new schema. We have the smiles. So this molecule generation model is going to store the search molecules by the user. So when a user copies a smile string and generates a molecules, we are going to store that as a history, right? So we have the smile string, we have the number of molecules, we have the number of similarities, particles, iterations, generated molecules, and we are storing the user as a reference. So later on, when displaying all the history of molecules generated, we don't want to just list every single molecule generated, but that associated with the user. So we have the user object here, and we have the created at and the timestamp to be true. So we export default to the molecule generation history. And finally, we have the group models. So the group model is very similar to the two that we've already created. So we have the message schema. So we are creating a message schema to be able to be used inside, the group schema. So the message schema is having a sender with a type The schema type is an object ID and we are referencing from the user. And we have the actual text from the user. We have the timestamp the text was sent. So inside the group schema, we have the created at, the name of the group, the created by, and the members of the groups are stored. We stored them in an array. And the messages are going to be of this basic schema. So the one we created here. And we export everything. So we export the group. So we have the models created. Now it's time to create the actions that are going to serve as a bridge to communicate, to the MongoDB database. So for this project, we are going to use resend for our email. So let's search resend on our browser. So resend.com. So resend is an email service that helps developers to send emails in their application. So we are choosing resend because of its easy integration with JavaScript, Next.js, and Node.js. Integrating resend in these frameworks and libraries is just a breeze. It's really easy to configure and get your first email sent. So that's the reason why we are using resend. And resend is free to some extent. So once you reach a cap of 200 emails per month, I think you have to upgrade to a different tier before you'll be able to use resend again. So that can be checked on the pricing section. And the documentation for resend include, Node.js, we have Next.js, and all these packages. So let's click on Next.js and move to get started. So we have to create an account to get started. So I already have an account. I'll log in with my account and you just click on sign up with Gmail and select any Gmail account you would want to create the resend account with. So once you create the account, you are being sent to this page, right? And you can click on settings or API keys to get, or create a new API key. So for this project, you're going to create a new API key. And so let's create one, ProteinBind. Add. So let's copy this key and save it inside the .env file. So back to the .env file, we are going to have resend underscore key and paste this key over here. Click on done. So let's move to documentation and learn how to integrate this in our Next application. So when we click on Next.js quick start, it shows us the procedure on how to install resend. You install it by running npm install resend, and we can create an email template, right? So we create an email template and create an API to send our emails. So inside the app directory, we are going to create an API service that is going to send the reset password and also the verify password. So you're going to follow this pattern by creating an email template and calling it inside the API page. So we'll get back to this in a second. So let's create the actions for the database first before we handle the email actions. So we are going to create an action for the user. So user.action.typescript. So this is the user's action page and we have userver here. So we are importing userver because we want this code to run at the server side. And we are importing revalidation from Next cache. So this bcrypt module is going to be used to hash the password and store the hash function inside the database. And we have the user collection imported over here. And we are calling this connect to database function from database Mongoose. So this function here. And we are calling the handle error function from utilities. So this one over here. So let's pretend we don't have these functions available here because we haven't created the email actions. So this function is just sending verification email and this is also sending reset password email. So I will elaborate more on this when we get to the email.action. So we have this async function create user, which accepts user as a parameter. So we have the create user params, which is a type for the create user. So inside the types directory, let's create a new type. And we are going to write index.d.typescript. So inside this index page, we are going to create the types for, the API functions that we are going to create. So I'll paste them here. We have molecule structure, which is a type for molecule structure. We have the molecule generation history type. So this is the create user param type, the one over here, which contains the email, the full name, password, photo, and all the other types that is required for the user. We have the update user params. We have the compound data params. So this is going to be an important type when we get to, the compound page where researchers can search for a compound and use them inside their drug research. And we have the modal props as well. So this contains all the props you'll be needing for, most parts of this project. So back to the user actions. So this create user function is having this argument, which is a create user param, which is a type of a create user param, and we call the try catch block. So before we create a user, we want to call this connect to database function, and we already have all the logic for connecting to the database. So we cached the connection if, it's available inside the cache, or we create a new connection. So we connect to the database and we create a constant named existing user, which we are going to find or check if the user email exists before we create the user. So if the user exists, we use the find one function from Mongoose. So we have the email field, and we are checking whatever email is coming from the user object. So the user.email, if this returns a result, if we have a user, we are going to throw an error saying the user already exists with this email. And we are going to hash the password over here. So the bcrypt function requires two arguments. So the first argument is the user password, and we apply a sort. So after we get the user password, we add a sort. So the sort is the parameter that is going to generate the hash for us. So the sort is to make sure that for every user password string that we enter, it gets hashed, with this sort number here, 10. And then we create a new user. So we have user.create. So we have user.create. So this user is coming from the model. The model we have here, this user object. So it's having a create, property to create an object. So we create the new user. We spread all the properties of the user, the email, the first name, and all that, the photo. And we provide the password field. So this is the hashed password. We can't store the string password here. That is going to be a security breach. So if our database gets hashed, we are going to leak all the password of our user. When you have user bio here, equals user.user.bio. So you are getting that from user bio. So over here, we provide a verification email. So as I mentioned, we haven't created any, email verification logic. So I will explain this section over again after we are done creating the email section. So we have process.next public API base URL. So let's add that in the .m file. And that is going to be localhost port 3001. So we have that here, and this verification URL is part of the argument that the send verification email needs to send an email for the user to verify their email. So I will explain more into details when we get to the send verification email function later in this video. So once we have the email sent, we are going to return the new user by passing using the json.parse and json.stringify. We return the new created user and we catch and handle any error that may occur. So this function is also for the login user. So to log in a user, we need the email and the password. So we connect to the database as usual and we create a constant user to, find a user with the email entered. So if the email used to register this application was test@gmail.com, you enter that and we find that email inside our database. And if the user doesn't exist or if the email is not found in our database, we throw this error and we check for the password match. So the bcrypt function, the one we used for the hashing of the password here, bcrypt, is having a function called compare. And what do we compare? So we are comparing the password that we are getting from the user and the already hashed password that we stored in the database over here. So we compare those two, and if there is a match, it's going to be true. So you're going to have true over here. And if there is no match, we are going to throw an error which says invalid credentials. And we return the new logged in user and give the user an access to the dashboard. So this function over here is verify email. So after a user has clicked on the link that has been sent to the email, we have to have a function named verify email to actually do the verification. So what we do with the verification is we get the user ID, find by ID, which is going to be a token that is going to be appended to the verification email URL. So once we get hold of that, we check to find the user. If we get the user, we update the is email verified option or field to true. And if there is no user, we are going to throw this error named invalid token or user not found. We return the found user and catch any error that may occur. And we have the request password reset, function over here. So when a user requests for a password, we accept the email as an argument. We connect to the database. We don't want the reset password to be just updating the password without verifying if the actual user is the owner of the account. So we create this function here, which searches through the entire database and find the email that the user has entered and return if we get a new user. So we have the reset URL here, which is going to be sent to the user's email. So this is one of the URL or the options that is required for the send request password email to work. As I mentioned, you don't have this yet, so I will elaborate on this more when we get to this section. We return true and catch any error that may occur. And we have the reset password. So this is the actual function that resets the password. So we accept a token and a new password as a parameter. Connect to the database, find the user by ID, and throw an error if the user is not found. So over here, we want to create a new password. So we create a constant for a salt and hash the newly created password and update it inside our database. So we have this, user.password equals the hash password, and we await and save the user object. We return the user object after everything and catch any error that may occur, and we have the get user by ID. So this is a function to get a user by ID. We connect to the database as usual. We get hold of the user by the ID. So the find one method is, accept an object. So the object, the first item is going to be the property stored inside the collection. And the second, the property, and the value for that object is the actual, ID you want to compare with the one stored in the database. We throw a new error if the user is not found and catch any error. This function over here is to update the user information. So a user may want to update their first name, their email, their bio, or photo. So this is the function responsible for that. So we call the find one and update method from Mongoose. So this is also going to have an object which is going to match the ID of the field or the collection that we want to update. So we add the user here. And so this is the user object that we want to update. So we accept that as a parameter. And we have new true here. So if there is an error or in case the user doesn't get updated, we throw this user update failed error, return the user, and so we have the delete user function, which is going to delete the user from the platform. So we find one by the ID, we find the user by the ID, and we use the find by ID and delete function from the Mongoose package and provide the ID of the user. And once we delete the user, we want to revalidate the path to this root URL. And we return the deleted user and catch any error. So initially, I wanted this to be a SaaS, a software as a service, but I got rid of it, to leave that for you guys to try on your own. So if you are interested in trying the update credit, you can work on that functionality for the project as well. And finally, we have the get user by email function, which does exactly what it is been named for. So it gets the user by email. So we find one, the find one function, accept the user as a parameter and look or search through the entire database, fetch the user with that email, and throw an error if we don't find any user, return the new user and catch any error that may occur. So that's basically everything that we have in the user's action. So I'll get back to this send verification email and send reset password email in a bit. So next, we are going to create the action for molecule generation. So we are going to have molecule generation.action. So what this is going to do, so let's paste the code for that over here. So what this is going to do is to, store every search molecule that the NVIDIA AI is going to generate into the database for a history, so that the user can get back their stored or search molecules. So we have use server as usual because we want this code to run on the server side. So we will not be using the revalidate path here, so we can get rid of that. And we are calling the molecule generation history collection from the models. So we have that one here. We import it over here and we have connect to database from the Mongoose function. We have the handle error utility function, and we have Mongoose imported as well. So the first function is create molecule generation history. We have the payload and the user ID. So we connect to the database and we create the molecule history by spreading the payload. So the payload is the properties that is required to create the molecule. So we have the number of particles, similarities, and decimal notation. So we return the new history and we catch any error, and we have get molecule generation history by user. So we don't want to list all the molecules that has been created for the application, but we just want to list the history by a user or for a specific user. So we have the user ID, we provide a string, and we connect to the database. We find by the user ID and we sort in ascending order, and we return whatever results that we are getting. So this find is going to, check through the entire molecule generation collection and fetch out where the user has created its molecule to render them. And we have get molecule generation history by ID. So we have the history ID and we connect to the database. We use the find by ID, provide the history ID, and this is going to look through the database and fetch all the molecule generations by this history ID. Return it and catch any error or handle any error over here. And the final function is delete molecule generation history, which is going to have an entry ID, and we are going to use the find by ID and delete function from Mongoose, pass in the entry ID and get rid of the molecule generation. So that is going to be it for the molecule generation, and we give that a save and create the function for group messages, right? The actions. Group.actions.typescript. We paste this code here. And what we are doing here is no different from the actions we've been creating, for the molecule and the user. So it follows the same pattern, right? We have use server, Mongoose, we import the model from group, the database models group. We have the connect to database function. We have the handle error function from the utilities. And to create a group, we connect to the database and we store the members. So a group is having a members, and these members are users of this platform. So they have their IDs, right? So the users are having their own IDs. So what we are doing here is to create a new set with the creator ID, the creator of the group, and we store the members ID by looping through the members ID array that we are getting from the group. So this function will be called in the message component, and we will know the data for this members ID. So this is going to be an array. We loop through them and we convert all the IDs to a Mongoose type object ID. So if we don't convert this into an ID, we can't reference and get all the user details by using its ID from Mongoose. So this is an important part. We create a new group using the create function on the model. We provide a group name created by the members. We catch the error and we have add members to group. So to add a member to a group, we just need the group ID and the user ID. So we find the group by the group ID and we push the user ID into the groups to make the user part of the group, right? And we have add message to group. So to add a message to a group, you get a group by the group ID and you store the message. So the sender's ID, which is going to be a user ID, and we have the message itself, which is going to be a text. We push the message to the group.message field inside the group collection and we save that. We return the group messages and we log any error that may occur. We have get group by ID. Using the find by one, we get the group ID and we populate. So the reason why we are using this populate function here is so we are storing the group members ID as a reference to the user collection. So this populate function is going to get any field that we are interested in the user collection, and we return that for the group, this group. So we return the first name, last name, and photo, and we return the members as well. So we throw any error that we may get and catch, handle the error for this side. A function to get all the groups. So find. So this find, without specifying any ID, is going to get all the groups from the group collection, populating the user ID section with the members, first name, last name, and photo. And we have the get group messages, which we are using the find by ID function from Mongoose to get the group ID. We populate it with the message.sender field, the first name, last name, and photo field, and return the message. So we handle the error over here as well. So now we have all the actions created. We have the user action, molecule action, and the group action. So what is left is the email actions. So let's create that. So we have email.action.typescript. So we paste that over here. So this action for the email is responsible for sending verification email and sending reset password email. So what we are going to do is to, when we go back to the resend documentation, it shows us the procedure on how to, send your first email. So let's create the email template, create the APIs for sending the emails, and then we get back to this page and explain every single line over here. So the first thing we are going to do is to work on the email template. So we are going to create a new folder inside the component directory named email template. And create these two files. So we have the reset email.tsx and we have the verify email.tsx. So for the reset email, we are going to import everything from React and create an interface for that. So we just need the first name and the reset URL. So we are exporting this component here, which accepts the first name and reset URL as an argument. So when we check resend, we can see this is very similar to what we have here. So we have the first name, and anywhere we call this function, we have to provide these two parameters, the first name and the reset email. So we have that, and we create a div for styling the email message. We have hello with the first name, and we add the following text. So we have, it looks like you requested the password reset. Click on the link below. So for the link, we provide the reset URL. So this is the reset URL that I was talking about at the beginning of the user actions. So this URL here, this very one here, this is for the verification. Where is the reset? So this one here, right? And template. And we have the paragraph here. So everything here is just a text, a paragraph. So we save that. That is going to be the template for the reset email. And the verify email is going to have a very similar pattern for that of the reset email. So we have that here. We create a props. We need the first name and the verification URL. So basically, it's the same thing as the reset password. And we provide the paragraph and the text. So we could even merge the verify and reset password together and make a condition. So we make the function send email template and provide and make a condition. So we are going to have an additional parameter which is going to say maybe the type of email to be sent, either reset or verify. And based on that condition, we return, a different paragraph to tell the user they are verifying their email or resending their email. So you can try that as an improvement for this code over here. I can't give everything for you guys. The learning takes place when you rip things apart and try to modify them into your own way. That is where the real learning happens. So I'll give this a save, and when we move back to the resend documentation page, so we have to create this API to handle the actual email sending. So back to the SRC, inside the app directory, we are going to create a new folder named API. And this API is going to have two folders. So you're going to have the send, reset, password, email folder. and send verification email. So we have those files created. So inside the send reset password email, we are going to create a new file named route.typescript. And we are going to paste this code here. So we are importing the reset password template that we just created in the component side, this one here. We import it from the component email template and we import resend. So we have to install resend. If you started with me from the starter file, you should already have it installed. And we initialize the resend object by typing new resend and providing the key for resend. So which when we click on .env, we have the resend key, which we added when we were signing up for the resend platform. So where I am, route.typescript. So here we initialize the resend, and so here we defined an async post function to handle the incoming HTTP post request. So we pass the request body as JSON and distract it to extract the first name, the email, and reset password. And we have this block here. We try and use the resend.emails.send. So this function is going to send the email, and so the from specify the sender of the email. So this could be the name of your support email address. So I'll just replace it with ProteinBind support resend.dev. And the to is the recipient's email address, which we are getting from this params, right? So the subject for the send reset password email is going to be reset your password, and we have the template. So the one we imported over here, we specify React and we add reset password template with the first name and reset URL. We throw any error that we get, and that is going to be it for sending the email for the send reset password. So this is really simple and straightforward, right? So we are going to repeat the same flow for the send verification email password. So for that, we are going to create a new file named route.typescript. So we have this code here, and this is basically the same as what we have in the send reset password email. So we have the sender email, the recipient email, the subject, and the email template, which we are passing the first name and verification URL. And we handle the error gracefully over here. So everything here is just to handle the error gracefully. So this is just the code we have in the recent documentation. So you can read more from their documentation website to enhance your knowledge on resend. So back to the code, we get rid of this, close everything here, and move back to the send verification email and reset password email. So send verification email and send reset password email. So over here, the send verification email is this function here, the one we are calling from the emails.action. So it accepts an email, the first name, the verification URL, and we are providing that. So when I move back to the users.action, we have the new user.email, which is the first parameter. We have the first name, and we have the verification URL. So this is going to be whatever base URL you have specified for this application, followed by a / verify email page, which we are yet to create, and we have the token as a query. So same thing happens to the request password reset. Same thing happens to the request password reset. So we have that as well, the reset URL. We have this page which we are yet to create, and we have the token as a query with the user.id. Provide that to the send request password email function inside the email.actions file, and we call. So over here, we call the API.send verification email, request. So this request here is going to be a post request and is going to send the email. So we have that, and we also call the API send reset password email when we want to reset our password. So this is going to send an email for the reset password. So that will be basically it. So we are done creating all the functions and APIs that we will be needing for authentication and communicating to the database, right? And also sending emails to the user using resend. So let's save everything and close all the tabs. So save this and close all the tabs. So next, we are going to create all the pages required for sending email, signing up, signing in, and everything that has to do with user authentication. So let's start by creating a user contest. So we create a new folder inside the app directory, and we are going to name it contest. And inside this folder, we are going to create a new file named user contest.tsx, and paste this code over here. So we are importing all these from React. Use create contest, use contest, use state, use effect, and React node. And we are calling the use section hook for handling user section data from NextAuth.js. So we are going to use NextAuth to handle the section, and for that matter, let's create the API for that. So inside the API, we are going to create a new folder named auth, and we are going to create a new folder again, which is going to be NextAuth, and inside the NextAuth, we create a new file named route.typescript. So this is the convention for creating, NextAuth in your application. So you create an API auth, you create the NextAuth folder, and then the route.typescript file. So inside the route.typescript, we are importing NextAuth from NextAuthentication. So this is going to help us in handling the authentication in Next.js. And we have credential provider, which we are getting from NextAuth/providers./credentials. So we call the login user function from the user actions. So this is going to be the function to actually log the user in. So we define the NextAuth handler that will manage the authentication flow. So this one here, NextAuth, and the providers contains, or we define the authentication providers over here. So in this case, we are using credentials provider, which is going to be our own custom provider. So we give it a name, credentials, and we specify the credentials object. We have the email, which is labeled as email, and the type is email. And we have the password labeled as password, and the type is password. So this credential object defines the field that the user will fill out in the login form. So in our case, we just have the email and password. And we have this authorize function here, which will be executed when the user submits the login form. So the function should return, the user data if authentication is successful. So that's what we have here. And else we want to return now if the authentication is false. So at this section here, we have the section configuration, which we have set it to expire after 24 hours. So we configure this to use the JWT, which is the JSON Web Tokens for storing the section data. And we have these callbacks here, which allow you to control what will happen after certain event in the authentication flow. So we have the JWT callback is triggered whenever we have a JWT created or updated. So that is what we have here. And if the user object is present, we want to add the user ID to the token. And we have the section callback here, which is triggered whenever the section is checked or created. So this checking here is to add the user's ID to the section object and return the section. So this will be passed to the client side to manage the user state. And then we store the NextAuth secret for the JWT sections cookies. We export the handler for both the get and post request to allow the authentication to work with both types of HTTP methods. So let's create this inside the .env file. And this secret could be anything at all. So I'll just name mine I love to code and give that a save. Save this as well and move back to the user context. So now we have the section. Anytime the user logs in, we have the section available inside Next.js. So we can get hold of that and do whatever we want to do. And we have the get user by email function to get the user data by email from our backend. And we access the section data using the use section from NextAuth, this one here. So this state is to store the user data. But before we store the data, we initialize this to a default values. So we have the default values for first name to be John, last name to be Doe, and we have the photo, job title, and the user bio. So we have this use effect hook which runs when the section emails changes or on component mount. So we have a function to fetch a user from the backend. So get user by email and set all the default values over here. So we provide the section.user.email as a dependency to call this hook or render this hook anytime this state changes, and return the provider component wrapping the children component with the user data. So we have this hook to access the user data from the user context. So we give that a save. So now we can create the sign in, sign up, reset password, and forget password page. So let's start with the sign in and sign up. So inside the app directory, we are going to create a folder named auth page and create two folders, sign in and sign up. So before we create the sign in and sign up component, let's create this very component named component header. So inside the component, we are going to create a new folder named component header. And inside the component header, we are going to create a new file named component header.tsx. And we paste this code over here. So what this code is going to do is to render the page name. So when we check the complete project and click on, let's say, molecule banks, and I log in and click on molecules bank, we have this header here. So this is what we call the component header. So we have created that, and we can move back to the sign in page and create the sign in component. So we create a new file named sign in dot. Okay, so let's just make it page.tsx because this is a page. And in Next.js, we have to name it page.tsx to be able to render as a page. So I'm going to paste that code over here. So we are importing the use client to indicate that this is a client-side component in Next.js. And we are importing useState, a link, and these icons from Lucid React. And the default layout as usual. So the sign-in component is supposed to, be inside the default layout component. And we have the component header, the one we just created. We have use router. We are importing use router to programmatically navigate between pages. And we have the sign in from NextAuth React. So this is going to help us handle the authentication with the NextAuth that we created over here, the auth and route.tsx. So we have the sign in from NextAuth React. So we define the component state using the useState hook. So we save the email, the password, error is loading, and we have the router. So this is going to initialize Next.js router for navigation. And this is the function that is going to handle the form submission when the users try to sign up. So before we talk about this handle submission function, this is how the component looks like. We have the sign in to ProteinBind. When I log out, so this is the sign in page, right? Sign into ProteinBind, and we have the input with the styles. We have the icons, mail icon here, and the password is having the log icon, and then we have the button here. So we are using the form. So we are using the form with an onSubmit handler. So this handle submit function is going to be called anytime the user click on the sign in. So we have that, and inside the handle submit function, we are preventing the default behavior on refreshing the page when the user click on the submit. We set the error to null and loading to true. So we have this, weak authentication here, just to check if the email field is not empty and the password field is also not empty. If that is the case, we set the error to please fill in all fields. So we try to save or sign the user in. So we call the sign in method from the NextAuth React here, NextAuth React, which we created our own credentials. So when we check the route, we created our own credentials here. So we call that, and we provide the email and password as we are expecting from the credentials, email and password. So once the user logs in and everything is authenticated, the user information section is being stored in the application. So that goes ahead and call the login user, and we catch any error that may happen or occur, and redirect the user to the dashboard page, the / indicating the home page. We redirect the user to that, and that's basically what we have in the sign in page. So basic stuffs. So next, we are moving to the sign up page. We create a new file named page.tsx. So this is the code for the sign up component, which is similar to the sign in. So we have React, use client imported, link, image, component header, default layout, and the create user function from the user.actions file. We import all these from Lucid React, and we check the sign up page. We have all these icons here. We are importing them from Lucid React. So we have the state for the sign up, which contains the email, the first name, and all the information that we'll be needing to create a user in our database. So this state here is to handle the selected profile picture. So we have a file selector here to store the profile picture. So that state is to handle that, and we set the errors. We have the is loading state to indicate whether the user is signing up or not. So this handler here updates the user state when the input changes. So when the user types their email, this is going to be the handler to handle the logic and save them to the respective state. And we have the handle file change, which is a handler to update the selected profile picture file. So we set the selected file to the state, and this is the function that converts the selected image to base 64 string. So initially when I was explaining how we are going to handle the image, I said we will be storing the actual image in the database. So we have to convert the image to base 64 string so that we'll be able to insert it inside the database. So we have that here, the logic here, and the validate form is going to validate the form fields before we submit. So we check if all these fields are not empty, and we return this message here. We check if the password, so signing up, we confirm the password. So we want to make sure that you're entering the right password. So we check if the password you entered doesn't match the one you entered in the confirm password. And then we throw an error that says password do not match. And we check if the image is uploaded as well. So this is the checker that is going to handle that. And this is the handle submission form function. So we prevent default from making this refresh anytime the user click on sign up. And we want to prevent submission if a submission is already in progress. So we set the loading to true. We validate the form using the validate form function, this one here. And if there is an error, we set all the error states and set the loading to false and set a submitting to false. So we try to convert the selected image file to base 64 string. We create a new user object with the form data and base 64 image string. And we create a new user object within the form. So we call the create user function to create the user from the users.action. And we set everything to an empty string after the user has signed up successfully. We handle every error. So this is the page, the code for the page. So on the sign up page, we have this SVG here. When I minimize this, we have this SVG here. So that is what we have over here. And everything here is just styling the input, creating the state for the handle submission. And that will be it for the sign up page. So let's move to the forget password and reset password page and test the user authentication all together. So inside the app directory, we are going to create these folders. We have the forget password and reset password. So we create a new file inside the reset password, forget password, sorry, to be page.tsx. And we have this code over here. So this code is also very similar to the sign up. We have use client to enable client-side rendering in Next.js component. We have the get user by email and request password reset from the user.actions. We have the default layout the use route, the mail icon, and use section from the NextAuth React. So we store the email input and the status of the request and potential error message inside these states. These ones here. So we have this section data here, which contains the user email when they are authenticated. So we have this set user to store the current user fetched from the backend based on the section. So we call or we fetch the user data if the section contains email. So we use this use effect hook here, and if the section.user.email, it means the user has logged in, and we fetch or we get the user by email using that fetched email and set the user to the state. So this is the dependency for that use effect. And we have the form to handle the reset password. So when the user visits this forget password page, so we ask users to send their email to get the form to reset their password. So if the status is idle, we render that page, which is going to have a title named forget password and a description saying enter your email to receive a password resend link. So you have that, and this is going to be the form that will submit the email. And when you click on that email, the status is going to change to success. And it is going to say we have sent a reset password link to your email. So when the user clicks on this email, it's supposed to take him to a page that will provide the form to reset the actual password. So this is what we are going to do. We are going to create that page. So this is the actual page to handle the reset of the password. So we create this page.tsx. So as always, we are importing the use client over here, and we are importing React use state from React, link from Nest link, and we have this icon from Lucid React. And we have the default layout page imported. We import the component header, and we have these two from Nest navigation. So we have the use router and use search params, and we have the reset password we are getting from libs user.action. So this is a state to manage the new password input by the user, and we have this state to store the confirmation of the new password. We handle the errors in the form, and we said that we have a state for that. We have a state for the success, and we have a state for loading. So we have the use router hook for navigation after we set the password. So we have these parameters here, the search params and the token, which we are going to get from the URL. So we extract the token from the URL, and this is the function that is going to trigger when the user submits the form. So this is the form for the reset password. We have the new password and confirm password. We have these icons here, and we have a loader to indicate, there is a process going on. And we have the bottom link that says don't have an account. So these links over here, these links over here. So we have a bottom link here that links the user to the sign up page if they don't have an account. So when the user clicks on the submit form, we are preventing the default behavior of the form to prevent it from refreshing the page after the user submit the form. We set the error state to null. The set is loading to true. So we have this here to check if there is nothing inside the password state, and it's going to set the error to please fill in all fields. And if the password doesn't match, we set the error to password do not match. And we have await reset password, which we are getting from this lib actions user.actions. So this one here, and we have a token and new password as a string. So that is being passed as a parameter for the reset password function. So we are getting the token from the URL, which we are distracting here, and we are getting the password from the state. So once everything is right, we set the success message to true to redirect the user to the sign-in page. If there is an error, we set the error here and handle the error gracefully over here. So that will basically it for the reset password page. So it's time to test all these together to see if we have the authentication set up correctly in this application, in this project. So back to localhost port 3001. We are going to refresh this page and navigate to the sign up page. So we have the auth page and we have the sign up. So this is the sign up page that we created. So we are going to create a new user. So let's just type Albert, and then email is going to be Ms. Albert. We set the password and we enter the password. So we enter the bio. This is a bio. We upload an image and click on the sign up. So hopefully this should work. So click on the sign up. So we have an error here which says registration failed. And when we check the VS Code terminal, it's saying couldn't connect to any server in your Mongo Atlas cluster. And one of the common reasons is that we are trying to access a database from an IP address that isn't whitelisted. So this is a common error that you may encounter when trying to connect to MongoDB. So I'll paste this in my browser and look for a solution in Stack Overflow. So what we are going to do is to add an IP address. So we move back to MongoDB, and on the security and network access section, we click on the network access and we have this over here. So we have to add this IP address. We click on add IP address and we have this modal opened. So we paste this IP address here, 0.0.0.0, and allow access from anywhere. So we click on confirm. We wait for some few seconds for the status to change from pending to active. And we try to see if you're going to get something inserted into the database. So you have the status change to active. So let's try it one more time to see if you'll be able to get something inserted into the database. So we try one more time. We click on sign up. Let's upload the image again and click on sign up. So you guys will realize we ran into an error when we were trying to sign up into the platform. And it took me more than 5 hours to debug this error. So I had to pause the video and complete the debugging before I continue the recording. So the issue we're having was, you see, we're having this port to be localhost port 3001, and MongoDB somehow was blocking this address. So I was having an issue connecting to the database on my MongoDB server. So what I had to do was to change this from 3001 to 3000. So once I changed this from 3001 to 3000, it worked fine. So that was the reason why we were facing that error. So let's test it out again. So let's sign up with this account. And this is my bio. We upload a picture. and click on the sign up button. Alright, so when we move back to the MongoDB platform and click on databases under the development title, we click on database and select or click on the browse collections. We should be able to see our model or collection name under the side. So we have ProteinBind and we have a user inserted into the platform. So when I click on this user, it should display the information the user inserted into our database. So clicking on user, and we have the email mensalbert@gmail.com, and the photo has been converted into base64 string as I mentioned earlier on. We have the first name, the last name, password, and is email verified. So I just got an email from the resend package that we used. So this is the email. So once I click on this link, it's going to show me the verify email page. So I'll click on it. So I just realized we haven't created any page for the verify email. So let's create that and refresh this page. So inside the app directory, I will create a new folder named verify email. And inside this folder, we create a page.tsx because this is a page. So I'll copy and paste the verify email code here and explain everything line by line. So we have use clients imported over here. We are importing React and use effects, use states as well. We have use router and use search params. So the URL that we got from the email is having a param, which is the token. So we are going to use that inside the verify email function that we are getting from users.action. So we have this state here, loading, success, and error state. So we get hold of the token by using the search params.get method to get the token. And we have this router to, redirect the user after the email has been verified. So we have this use effect, constant verify user email, which is an async function, and it checks if there is a token. If you are getting a token from the URL being sent to the email, we call the verify email function. So when I inspect this function, it's coming from the user.actions and it accepts a token. We connect to the database and we find the user by the token. So once you get hold of that user, we update the email verify, the is email verify field to true. Back to the verification page, we save or we set the status to success and we catch and handle any error that may occur. So we call this function. So as soon as the token is being detected, we want to recall this use effect or re-render this use effect. Inside the component itself, we have this circle check big here to show that the email has been verified. So if the status is loading, we show verifying email, please wait. And if the status is success, we shows the email has been verified successfully. So the status only shows or gets updated to success if we have successfully, verified the email here and we set the status to success. And if there is any error, we display this error. And we have, when the status is success, we want to display this button here that says go to sign in page, where the user can sign in. So I'll move back to the browser and refresh the token page. So it says verifying email, and we have this email has been successfully verified. So it happens really quick. And when we check the database, refresh it over here, we should see it's verified to be true. So we scroll down and we have is email verified is updated to true, meaning this email has been verified. So that is how you can implement email verification in your application. So back to the localhost, I can click on go to sign in, and it takes me to the sign in page. So over here, we can log in. So let me try and log in with my email, the one I signed up with, and the password has been saved. So I'll click on sign in, and boom, we are being redirected to the dashboard page. So everything is working fine. So let's test the forget password as well. So auth page, sign up, and I'll click on the sign in and click on forget password link. So click on reset. Okay, so you have an error here. Use section must be wrapped in the section provider. So back in the root layout, we were supposed to wrap the layout with the section provider. So back in layout, so this layout, this one here, we have to wrap this page inside the section, the section provider to be able to use the section, and also the user provider. Since we've created the context already, we can wrap that around the layout page as well. So over here, we are going to import the section provider and the user provider. So we import the section provider and import the user provider, which we've already created. So we scroll down a little bit, and so right after the body, we're going to wrap this the use section and the user provider around the children element. So we have section provider, and user provider. We give that a save. Later on, we are going to add other providers, but that would be in the chat section. So when we get to the chat section, we are going to import ably provider, which is going to help us in the real-time communication between researchers. So since we haven't implemented that, we are going to leave that alone. So I will save this and move back to the page. So we have forget password, and when I enter my email, click on send reset link. So it says check your email. So when I check my email, I should see a link that is going to lead me to reset my password. So I'll move back to my email and I click on this email here. It says, hello Albert, it looks like you requested a password reset. And when I click on this link, so let's copy this link and paste it inside the browser. So we have the reset page available to us. So what we can do here is to, change the password. So I can enter a new password and click on reset password and have my password reset. So now we have the sign up working, verifying email is working, login is working, and reset password is also working. So that's how you implement this in your application. Very simple and straightforward. So next, we are going to move back to the layout page in the component directory, this layout, and click on default layout. So we want to add a couple of things here. We want to protect all the pages in this application. So if a user hasn't logged in, they shouldn't be able to access any part of this application. So to do that, we are going to need the following. So we are going to create, a section, a hook to retrieve the user section and check the user status if the user has logged in or not. So we create a constant data section and we get a status as well. So we are going to use section from NextAuth. So we import that use section from NextAuth. So we are going to use router and use path to redirect the user to the sign in page if they haven't signed in and try to access the pages that are protected. So we have that import over here. And we are going to call router, create a variable to hold use router. And create a variable to hold the path. So const path name is going to be use path name. So technically, we want to protect every single page on this application. But some of the pages are supposed to be exceptional since the default layout is wrapping around every single element in the application. So like the sign in page, the sign up page, the verify email page, and the reset password page are supposed to be public routes. So we don't want this to be protected because if the sign in page is protected, how then is the user going to sign in or sign up? So we have a constant to name the public route. So public routes, and these are going to be the public route. So we have the auth page, sign in, sign up, verify image, reset password, and I think we have to add forget password page as well. Forget password page. So these are going to be the public routes that we don't want to protect. So this use effect is going to handle the redirecting if the user hasn't logged in on their application. So you have this use layout effect. And so what this is going to do is to run after the layout has been rendered. So we are going to check if the user is unauthenticated and the current route is not one of the public routes, we redirect the user to the sign-in page. So we have if status equals unauthenticated and the current route is one of the public routes, it's not one of the public routes, we have this exclamation sign here indicating not dot includes the path name. We want to redirect our user. So router.push, we have auth page and sign in. We want to redirect the user to the sign in page. And these are going to be the dependencies. So when the status changes, when the router changes, and when the path name changes, we want to call this use layout effect. So we have that. And that will be it for this page. That will be it for this page. So we have the protected route, implemented. Means the my profile page, account settings, and logout functionality. So to do that, so we are going to do just that. So when I click on my profile, it says page not found. So we don't have the profile page created. So let's create that and work on the settings and logout. So we are going to create a new folder inside the app directory and name it profile. We have the page.tsx because this is a page, tsx, and we have the profile page code over here. So we are importing use client. We have the image from Next. This is the default layout. We have the camera icon and the use user context. So we want to access some of the information of the user. So we want the user profile, the username, and the bio. So we create a constant to hold all the user in the user section. So we have the user equals use user. And when we scroll down, and check this side here, we can see the image is having the src to be user.photo. So we are getting this from the use user context. So back here, remember we are saving everything inside the section to be able to access it at everywhere in the page. So to be able to access this at everywhere in the application. So we have the user.profile to display the profile, and we have the user.first name and last name to display the username. We have the job title here, and we have the about me, which is going to be the user bio. So initially I wanted to add the contribution count. So any message the user has been sent to any researcher, we have the count, we store the count and display it over here. But I left that out for you guys to try and implement it on your own. So trying these things out is where the real learning starts. So try and implement this on your own. So I give this a save and move back my profile. And there we go, we have the profile over here. The reason why the profile hasn't been updated at this side and the name is because, remember, we are hard coding this header section. So we move back to this component and we make sure we are getting the information from the login user. So let's move back to the header component and the use and the user drop-down component to change that. So we move to the header component, drop down user, and we do that over here. So we are going to call the use user context from the context that we created. So we create a constant user and use the user context. So that will give us access to the information of the currently logged in user. So we have that, and we can change the name over here by typing user.firstname, and we have user.lastname. We save this, and the job title is going to be a researcher. We have the image. So this is hard coded. We have to change this to user.photo. And that will be it. So let's implement the logout functionality. I will uncomment this and implement the logout functionality. So we create a function named handle logout, which is going to be an async and async function. So we are going to use sign out from NextAuth React. So let's import that. And we call the sign out. We pass in the redirect to false, property to false. We push the sign in page, and then we redirect the user to the sign in page. So router.push, and we have auth page sign in. So this redirect here is to perform the sign out without automatically redirecting. We want to do it programmatically. So that's why we added the redirect false here and redirected it programmatically over here. So this should get the logout working. And when we move back to localhost port 3000, we have the profile icon here and we have the username here. So let's move to settings. We have my profile implemented and logout functionality implemented. So let's move to the settings, account settings. So we create a new page inside the app directory, named settings, and have the page.tsx. I'll paste this code here and explain everything line by line. So the settings page is very basic. We are importing all these use client default layout and the dark mode switcher that we created earlier on over here, and we are importing all these icons from Lucid React, and we need the use section from NextAuth React as well. We have use state and use effect, and these two functions from the user actions, so the get user by email and update user, because on the settings page here we want the user to be able to update their records. So we distract the section data from NextAuth, and we initialize the state for the user data, including the name, the bio, photo, and ID. And we initialize the state for handling the selected image file for the profile picture. And we have a state to track any error during the form submission. We have a state to handle the loading behavior during async operations. And we have this use effects function here to fetch the user data from the API once the section is available. So here, if the section contains the user email, we fetch the user data and we set the user data inside the settings input fields. And we have that here. So this is going to be the function to handle the personal information submission. So we have all the information in this state here. This React input, we store the user data in the state, email, the user last name, the first name, and all the information that the user can edit. We store that, and we prevent the default behavior of form from its refreshing anytime we click on the submit button. We set the is loading to true, and this is the updated user information. We get that from the user data state. And if the user data.id exists, we want to do the update. So we check for the user data ID and we update the user using the update user function in the user.actions API functions, which accepts an ID and the user object. So we update that, set loading to false, and handle any error. And this is going to handle the image upload section. So for this settings page, we are handling the personal information separately and handling the image update separately. So we go through the same procedure. We convert the image to base64 as we did in the sign up page. We check if the user.id exists, and once we know that the ID exists, we want to create an object to hold all the user information. So we spread the existing user data and have the photo field here, which is a base64 string. We update the user using the update user function from the user.actions API functions, and we set the user data to the updated data. We handle any error. So this is the function to convert the image to base64. So very similar to what we did in the sign up page. And this handle change function is handling every single input field here. So it determines which type of input is updated inside the user state, the user data state. So we have that, and this is the handle file change. So when the user upload an image, we save the image file inside this state and set the user data to the photo URL. So that is basically what is going on in the settings page. So I'll save that and move back to the localhost and click on account settings. And there we go, we have everything here. So when I try to update the bio to this is an updated bio and click on save. When we check the database, refresh this, we can see we have this is an updated bio. So everything is working perfectly fine. So we are making a good progress. So we are done handling the user authentication and flow. So let me try and log out. Before I log out, let's test this thing here, the toggle theme. So we have the toggle theme here to switch between the light mode and dark mode. So we are importing that over here. The dark mode switcher over here. And I click on it, it turns everything to dark mode. So I click on log out and it takes me to the sign-in page. So let's try and access any other page to see if we'll be able to access it. So I'll click on the dashboard page and quickly it redirects me back to the sign-in page. So this is working. The default layout and protected routes are working perfectly fine. So next, we are going to work on the molecule bank, the model, research, and messages pages. So starting with the molecule bank, we create a new folder inside the app directory named molecule bank. So we create a new file named page.tsx. So before we write any code for the molecule bank, let's create a component that is going to hold all the molecule in a table form. So we back to the components directory. We are going to create a new folder named molecule bank and molecule structure. So the molecule structure is going to be the component that will convert the small string into an image, as we demonstrated in the demo section. So we have a small string and we have a package called the RDKit, which is going to convert it into an image. So we create an index file. So this is the RDKit package, and when you visit this website, you can learn a whole lot of things over here. We have the small dynamic. So we have these small structures generated using this package, and we have SVG rendering, canvas rendering, substructure highlight. So these are all the properties or some of the things you can do with a small string using the React RDKit. So we have this section here to test everything out. So what we are interested in at this page is the molecule structure component. So when I click on C code, we have this code that is going to be the function to handle all the molecule generation. So we are going to work with this code. So back to the VS code, we paste that over here, and that is going to be the code to handle the small string to the SVG image. So I don't want to go through every single step of this code, but just know this is how it works. It's going to magically convert the smalls to an SVG. So I will explain some of the props and not every single thing in this code. So this function here initializes the RDKit modules and ensure it's loading once. So this is basically what this function is doing here. So this is the component for rendering the molecular structures using the RDKit. So we have a constant to define the molecule structure, and these are the props. So we have the ID of the canvas of the SVG, so canvas or SVG element. We have the optional class names for styling. We have Boolean to toggle between SVG rendering mode. We have the width of the molecule rendering, the height of the molecule rendering, and we have this structure property here is to define the small structure of the molecule. We have optional substructure for highlight, and so on and so forth. So we have this core props, which is going to display below the rendering. So these are the default props, and this is a constructor. Sets everything. And we have this method to handle drawing either as an SVG or a canvas element. So this method is to get the rendering details, including the highlights for substructures. And we have component mount. This is the component lifecycle method to load RDKit when the component mounts. And we have this one over here, component mount, the lifecycle method to update the molecule rendering when the props changes. So we have that. So this render method is to conditionally render SVGs or canvas based on the props and the RDKit state. So that is basically what is going on over here. So back to the molecule bank, we are going to create a new file named molecule bank table.tsx. So this is the component for the molecule bank. So the main idea for this component was to, list some few examples of molecules and their small structures, molecular weight, and category usage. So yeah, that is the main function of this page over here or component over here. So we are displaying everything. We have this array that stores all the molecules and its properties, and we loop through them over here and display the molecular name, the small structure, the molecular weight, and category usage. So notice we are calling the molecule structure over here, the one we created, and passing in the ID. And so the ID is part of the props, and we are passing the structure, which is going to be the molecule.small structure. So we have the small string, and this is going to render the small string as image. So I'll save this, and before we move back to the molecule bank page and test this out, I want us to add this here. So inside the layout page, as part of the installation of the RDKit, we have to add a script. We have to add this script here, which is going to help the RDKit work fine. So we have to just add this here in the layout page. We give that a save. We move to the molecule bank page. So this is the page for the molecule bank. We are calling the component header to display the header or the name of the component. And we have a molecule bank table from the component that we created here. Molecule bank table, this one here. So we are importing that and wrapping everything around the default layout. So that is the page for the molecule bank. So let's give this a save and move back to localhost port 3000. Refresh the page, sign in, and click on molecules bank. And voila, we have the molecule bank page rendered. So we have the molecule name, the small structure, molecular weight, and category of usage. So with the power of RDKit, we are able to convert a small structure. So when we check the molecule bank components, these are the small structures, into an image. So this is what we wanted, rendering beautifully and looking amazing. So our next target is to work on the model page. So we are going to use the power of NVIDIA to generate molecules based on a small string. So this is an NVIDIA platform that have models available for learning and development purposes. So under the Discover tab, we have all these models, a couple of models to play with. So what we are interested in this page is under the biology section. When we scroll to the right, we have this model here named MoleMen, an NVIDIA model that helps in drug discovery. So what this model does is to perform controlled generation, finding molecules with the right properties. So this is what we are interested in, and I will click on this model. So it shows me how to use this model. You input a small string, add these parameters, and run it to generate all these small images. Okay, it's having a scroll as well. So this is what we want to implement at the modal section. So we can click on view example to get access to a couple of small strings. When we click on shell or Python, it shows us how to use their API to implement this in your own code. So I will click on the shell, and over here we have the URL, and we need an API key from NVIDIA. So we click on get API key, and it will ask you to sign up before you can use the API key. So I have already signed up and I have my API key. So to do that, click on login. It will take you to the sign up page. You sign up and move back to this exact page and click on get API key to get your API key. So back to VS Code, we are going to create a new component and page name called model. So the page is going to be model, and we have page.tsx. So this is the code for model page, and I am going to explain everything line by line. So don't get worried or get scared of whatever you see over here. So we import use client to indicate that this file is meant for client-side rendering in Next.js. And we import the component header, import default layout, and import molecule structure. So we have this molecule structure component, which is going to convert the small string into an image for us, like what we saw on the NVIDIA platform. We have use state and use effect, and we have use section, because we will be saving all the results that has been searched by the user into the database. So you have to get the user email using the use section. So we have the create molecule generation history and get molecule generation history by user functions over here, which I will elaborate more later on in this page. And we have the get user by email function from users.action. So here we fetch the user section, and we have a state that is going to hold the form input and the result. And we have this state to store all these parameters, which are going to be important in sending the request to the NVIDIA API. We have the history and we have the user ID state over here. So we want to fetch the user data by using the section.user.email. So we get hold of the user by using the email and save the user ID inside the state. So what we want to do here is by using the user ID to get all the search molecules by the user. So we call the get molecule generation history by user function here, which accepts a user ID as a parameter. So that is going to give us the results from the server. We save that here and set it to the state to display it as a history. So this is the handle submit function. So before we tackle the handle submit function, the model page is a form. So we have small string, the input small string, we have the number of molecules and all these parameters which are going to be stored in the state. And when a user clicks on generate molecules, all the states, all the small string, the minimum particles, the number of molecules, particles, iterations, and all that are being sent to the NVIDIA API URL. So we have e.prevent default to prevent the form from refreshing anytime you click on the generate molecule. So this is my API key from NVIDIA. So we paste that here, and this is the URL which we are going to send the request to. So the payload is having these properties. So we have to specify the algorithm, the number of molecules, and all these. And we use a post request to, send all this payload to the URL with the API key. And once that is being sent to the server, we wait for the response. So we get back. So what you're going to get back from NVIDIA is an array of small strings and a score. So what do you do with that? Well, we pass the data and store everything inside generated molecules and set it to the state. So if the user exists, what we are going to do is to store all the generated molecules inside our database using the create molecule generation history function. So we store everything with the user ID. And here we update the history. So once we save it inside the database, we want to fetch it back to update our history. We handle any error here. That may occur. And that is going to be it for this component. So this is where we are rendering the molecule structure either from the history or the NVIDIA API. So yeah, that is it for the model page. We save this, move back to localhost port 3000 and click on model page. So we don't have any history here, anything saved in the database because we haven't generated any small strings. So when I click on generate molecules, we have all the molecules generated under here with their scores. So we are getting this from NVIDIA AI, and we have the history over here which has been inserted into the database. So when I move back to Mongoose, refresh this page, we have the molecule generation history which have been saved for us. So that is working as well. So this is great and beautiful, very beautiful and great. So drug researchers know the uses of this. So generating similar molecules, helps them to come up with a drug or help them in the drug research. So this is powerful and wonderful. So yeah, that is it for the model page. So next is the research page. So we create a new folder inside the app directory and name it research. We create a page.tsx, and so this is the page for the research. So the research, all we are doing in this page is to send a request to this URL. So the PubChem URL. So this PubChem platform is an open platform where researchers can search for compound and get their properties, which is going to help them in making drugs or help them in drug research. So when we search the PubChem platform, you can read more on how this works. So this is lengthy and I can't, go through line by line. The link will be provided in the description. So you can check this out and understand all the fields and the results you can be expecting from this PubChem API. So we send a request to this API and it gives us a response back. So the response contains properties like molecule formula, molecular weight, in chain key, all these properties that helps drug researchers. And when we get the results back, we set that in the state. So we have a state here, we set all the results in the state and we display them over here. So we display them in sections. So we have compound data. Once we have a result in the compound data, we display all the properties. And that will be it for the research page. So in a nutshell, we are sending a compound name. So a user can search for a compound like aspirin or coffee. And this API is going to, generate a response and send it back to us with all the properties that we have defined here. We save that and render them in the component, display them over here. So I'll give this a save and move back to localhost port 3000. Click on research. And over here, let's search for aspirin. So aspirin, click on enter. And there we go. We have all this information coming from the API that we sent the request to, the basic information, the physical properties, the additional information, and what have you. So this is amazing and can help drug researchers in conducting their research. So the final piece we are going to tackle in this project is going to be the messages section. So for the real-time message section, we are going to use this platform called Ably. So Ably is a definitive real-time experience platform built for scale. So these are some of the things we can do with this platform. So we can create a live chat, a data broadcast, data synchronization, multiplayer collaboration, GPS location tracker, notification, and many more. So this platform is going to help us implement the real-time chatting functionality for this project. So when you visit this platform, you have to create a free account. So once you create a free account, you are being sent to this page. So if you don't have any app created, you create an app. But since I already have an app created, I will click on View App. And on this page, I'll click on API keys. So this is where you get your API key. You can create a new API key if you don't have any. But since I have one here, I will use this API key. So once you get hold of your API key, we move back to this documentation page or website. So what we are going to use for our chatting is what we call the PubSub architecture. So the PubSub architecture works this way. So we have a publisher and a subscriber. So a user subscribes to a topic, and anytime the publisher publishes under that topic, everyone subscribed to that topic gets a message. So this is how the PubSub architecture works. So we have a publisher. So let's name this publisher, and we have a subscriber. So this is what happens. The publisher is having topics. So the topic could be topic 1, and we have topic 2, and so on and so forth. So it could be about anything, literally, and we have a subscriber. So a publisher publishes under a topic. So this topic could have messages. So the messages for topic 1 could be something like, hey, I am communicating through topic 1. And same thing happens for topic 2, communicating through topic 2. So the subscriber, on the other hand, subscribes to a topic, right? So this subscriber can subscribe to topic 1. So subscriber, we have topic 1. So anytime a publisher publish a message to topic 1, the subscriber gets the message in real time. So if the publisher updates this message, once the subscriber has subscribed to this topic, he gets the message in real time. So it doesn't matter the number of message the publisher sent, the subscriber is going to get that message in real time. So in our application, we have groups, right? So a user creates a group and we have multiple members in the group. So we can have 2, 3, or maybe 4. So, let's make them 4 members in the group. In terms of PubSub, this is the publisher. So the owner of the group is the publisher. So all these users have joined this group by the group admin. So the group name, let's name it group 1 or J1. And all these users have subscribed to J1. So as soon as J1 send a message, it gets broadcasted to every single individual who have subscribed to this group, right? So if this actor send a message in the same group, it also gets broadcasted to everyone who have subscribed to that topic or that group. So that is how the PubSub works. So this is a quick explanation on PubSub, and I believe this helps you understand or conceptualize what we are trying to do in this project. So back to the documentation, we can read more on this and understand how the PubSub works and check how to implement this PubSub in your own. So back to the VS Code, we are going to create a new folder in the app directory named message. And inside the message, we are going to create these 3 files. So we have chatboss.jsx, we have chat.jsx, and we have page.jsx. So before we even start writing anything for the message page, back to the layout, we have to add this. So layout, this one here. So to make an ably work, we have to wrap the whole component into an ably provider, like what we did for the section and user provider. So at the top here, we are going to import ably and ably provider. Scroll back, and over here, we are going to initialize the ably client with the API key for the real-time messages. So I'll paste this here, and we have client new ably. This one we are importing over here, .realtime, and we have the key. So I'll copy my key, API key, show this and copy this key, paste it over here. So we have to add this and give this a save. Give this a save. So we have the initialization of the ably client. And next, we are going to wrap everything around so here, we wrap everything around the ably provider. And we provide the client, the one we initialized. Next, we are going to wrap this around the channel provider. So the channel provider accepts a channel name as a prop. So we have to provide the channel name. And for this one, you name the channel chat demo 1. So keep this in mind. We are going to use it in the message component. So chat demo 1 or whatever name that you give yours. I'll save this and move back to messages. So we are going to write the component for the chat. We are going to import the following. So we have React, use effect, use state, use ref, which is going to track the position of the message and scroll to the recent message. We have use channel, we have use ably, we have default layout, send icon, use user from the user context, and we have resize base 64 image. And we have all these actions from group.actions. Create group, get all groups, send, add message to group, get group message. And we have get user by email and use section. So we are going to create a function for the chat boss. So we have chat boss and we are going to create a constant to hold the ably instance. So we have const ably equals use ably. And we have a constant to hold the groups. So when a user creates a group, we have to hold them in this state, which is going to be a use state. And we have this state to hold the current group, this state to hold the message text. We have this state to hold the messages and this state to hold the current user. And we have a channel name, constant channel name. So remember, the name should be the same as what we had in the layout. So if you named this a different thing, we have to use that inside the channel name section. So messages. And we are going to have the section data from NextAuth. So we have that here. And we create a constant to get the user data from the context. So user equals use user. We give that a save. So next, we are going to create the ably channel. So we create a constant. We have channel equals use channel, the one we imported over here. Use channel. And we provide the channel name. We have message. And we have if message dot data, the group equals the current group ID. We want to set messages. So we have previous messages. And we spread the previous message and add the new message data. So this is going to create the channel for the real-time message communication. So you can read more on the ably documentation website to learn how to implement this. And we have a constant. We create a constant here, named it bottom ref, which is going to be use ref and initializes to now. So this is going to be used for automatic scrolling to the bottom of the chat box. And we have this use effect function here, which is going to scroll to the bottom when a new message arrives. So next, we are going to create a use effect to fetch the groups and user data when the component mount. So we have that here. So remember, we are saving all the groups in the database. So we fetch that and set the groups, all the groups for the user inside the group state. and render that at the front end. So that is basically what this use effect is doing. So this is a function that is going to create a new group. So we pass the group name as an argument, and we have await create group. So this is going to create the group using the create group function that we are getting from groups.action. So we have that saved in the database. So next, we are going to create a function that is going to allow a user to join an existing group. So we have that here. So we find the selected group using this line here. We loop through all the groups and find the selected group by the ID and set the current group to the selected group. So next, we have the group messages which we are getting from the database. We fetch all the group messages using the group ID and format the message to be displayed in the group. So when the user joins a group, all the messages in that group are being seen by the user. So that's the function to handle the group join. So next, we are going to create the function that is going to send message to the groups. So we have the send message function which accepts the message as a text and check if the current group and channel exists. So we resize the image. So the reason why we are resizing this image is we want to display the user image when a message is being sent. So the name of the user, the image, and the actual message text is supposed to be sent as a message. So we have the message object, which is having the name, the image, the data itself, which is going to be the message text, the timestamp, and connection ID. So we use the channel.publish function to send the message and add the message to the database using the add message to group function. This one here. So that will save the message in the database as well. So next, this is the function that is going to handle the submission. So we have handle form submission, send, we are calling the send chat message, this function here. We pass in the message data and that is going to be sent. So first, we broadcast the message to every user that has subscribed to the group, and then we save the message in the database. So this is going to be the function to render the chat messages. So we have this is me state here, which is checking whether the message sent was sent by the current user. So we need this to style the message form or the message component. So if a message is sent by the current user, we want to display the message on the right hand side, and incoming messages are to be displayed on the left hand side. So we have that, and everything here is just a styling to justify end or justify start the message component. So finally, we are going to return the actual body for the chat box. So this includes the form to handle the send message and displaying all the messages. So we are going to wrap everything around the default layout. And we have this component over here. So what we are doing here, we have the title named drag discovery chat. And this is for the groups, to select a group and create a new group. And this is to display the messages for the group. And this is the form that is submitting the message. So everything is working fine. So finally, we are going to export default the chat box so that we can use it in other components. So let's move to the chat.jsx and import the chat box over here. So we have use client, and we are going to import the chat box from the chat box, this component. We want to export this component. And we return the chat box component. So we move to the page. So in the page.jsx, we have use client. and we are going to import chat from chat and create the component for the page to return the chat component. So we return the chat component and export default page. So we save this and move back to localhost port 3000. We click on the messages section and we have the messages page. So we don't have any group yet, so we have to create a group and test this out. So the name of the group is going to be test group, and the group has been created. So there is no message yet. So I will open a new browser to test this real-time communication. So we have these two browsers open side by side. When I send a message like hello world and click on send, in real time, I see the message being sent. So the message has been sent and broadcasted to everyone in the group. So I can try and send a different message. Hello world, this is going so smooth. Send, and we have it over here. So the chat is working fine.